In this example, I'm going to show you how to find the limit of the function h. I'm going to show you how to find the limit of the function h by reading the graph, and then I'm going to show you how to use algebra to find the limit. Part A. I'm looking for the limit of function h when x goes to 1 or x approaching 1. To do that, we have to find the limit of the function when x approaching 1 from the left-hand side, and then we have to find the limit from the right-hand side, and then we compare overall. So here's our target right here, is 1. This minus here means I'm looking for the limit of the function from the left. So I want to find the limit of function h when x goes to 1 to the left, meaning I want to know what is my function h become close to or close to when x go very close to 1. So if you walk from here toward to 1, very close to 1, and you see that when you look up, your y value is very close to 4. So I look up here, my y value is very close to 4. So that's my limit. So in other words, when x go very close to 1, h go very close to 4. Now I would not go down, I would not look down to read this value, because when I walk very close to 1 from the left, this line here is my domain. It's dominated by my view. So therefore I look up. So when I walk toward to 1 from the left, my function is up here, not down here. So therefore I read 4. Same thing, when you go to 1 from the right, when you go very close to the right, your domain is dominated by this line here. So I'll read down. So when I go to 1 from the right hand side, my y value or my function is go very close to -2. So I approximate -2. Now because the limit from the left and the limit from the right is not the same number, so therefore my answer does not exist. To be exist overall, these two values here has to be the same. Now let's look at find limits for the same function using the algebra. So once again, here's my target is x, is a 1 here. I'm looking for a limit when of a function when x go to very close to 1. So here's me. I walk very close to 1, very close. Okay. Now when I walk very close to 1, I stop somewhere around here, like right here I have 0, so around here I have like 0.99. Now 0.99 is less than 1. 0.99 belongs to this domain here. Therefore, to find the y value when I go very close to 1 from the left, and read this domain. So I take 2 times 0.999, it's very close to 1. Plus 2. But 0.99999 here, when you do the calculation, it goes very close to 1, so you approximately equal to 4. Exactly I have here. Now when you look for limits from the left hand side, you can do the same thing. You can go to number 1, when x go to number 1, very close. We want to go so close to 1 on the right hand side. When you go to right on the right hand side, you stop right here. It's about 0.0001, so close. Now 0.001 is actually greater than 1, so therefore that value belongs inside this domain. So I'm using 2 times 1.00001 minus 4, which is approximately -2 when it goes from the right. Because my limit from the left is different from my limit on the right, therefore the overall limit is do not exist. That's our answer. Now let's look at part B. I'm looking for a limit of the same function, but now I'm going from when x approaching minus 3. Right here is minus 3. Right there is minus 3. Now this minus outside here means I look from the left hand side. So I look at my target, or I approach my target from the left. When I go very close to minus 3 to my left, my y values go very, very close down here. I'm reading very, very close to minus 4. So here's my limit is minus 4. Then we look at our limit when x approaching minus 3 from the right. So here's me again. I'm approaching my limit to minus 3. Remember, this arrow here means approaching very close. So therefore, please go very, very close to minus 3, but not exactly minus 3. You go very close. So when you go very, very close to minus 3 from the right, naturally it will look down here to read the function, which is h value, which is very, very close to minus 4. So therefore, because my limit from the left is equal to the limit, or the same limit from the right, therefore overall limit is minus 4. We can solve part B by using the same methods that I did earlier, by using algebra, by reading what we have here. Remember, these are our domain here. This is called piecewise function. So when we look at the limit from the left, this means we're asking ourselves what happened to our function when x goes very close to the minus 3 from the left. So right here is me, I walk very, very close to minus 3. Here's, remember, here's 0, here's minus 4. So when I go very close to minus 3 from the left, this value here is like minus 3.001. Okay? Now minus 3.001 is less than 1 because of minus number. So therefore I'm reading this domain here, and this domain here belongs to this line. So I put 2 times minus 3.0001, very close, plus 2. So when you take this here, I have very close to minus 6. Plus 2 is approximately minus 4. You can do the same thing when you find a limit when approach minus 3 from the right. When I go from the right, I go approaching here very close to minus 3. Right here, approximately minus 2.999, very close. So take now minus 2.999 also belong inside this domain because minus 2.999 is less than 1. So I'm using this line here to evaluate my limit. I put minus 2.99999 and so forth, very, very close to 3. Now you take 2 times minus 2.999 is almost like minus 3 times 2, which is minus 6 plus 2, approximately minus 4. Because my limit from the left is the same thing as my limit from the right, which is minus 4. Therefore, my overall limit is minus 4. So now is my answer.